Fine. So, yesterday we discussed about, we talked about the basics of environmental ecology, wherein we discussed, firstly the basic terms of environment, ecology, then various levels of ecological organization, right? Under that, under the level of community, we have discussed about various biotic interactions, right? The interactions between different species, fine. So, what are the different interactions that we have studied? Primarily, major group 3, positive, negative and neutral. Under positive, we have discussed about symbiotic. Under symbiotic, we discussed about under positive, we discussed about mutualism. Under mutualism, we discussed about symbiotic and non-symbiotic or asymbiotic mutualism. And second type of positive interaction was commensalism, right? So that we discussed under positive. Under negative, we discussed about competition, predation, parasitism, and also amensalism, right? Amensalism. Under amensalism, we have referred to that term allelopathy, right? Then we discussed neutral interactions as well, and those interactions are the most widespread, most prevalent form of biotic interactions, right? So that we have discussed under community level of ecological organization. Then we studied about the ecosystem, right? Ecosystem. Under ecosystem, firstly we discussed a basic structure of ecosystem where we have abiotic components. Those abiotic components are primarily used by, let's say, producers. Producers use those abiotic components to produce their own source, own energy, which is transferred to the consumers, and from producers and consumers towards decomposers, right? So that basic structure of ecosystem we have referred to yesterday. Also, we started discussion of functions of ecosystem, right? And under functions of ecosystem, what we have discussed? Under functions of ecosystem, what we have discussed? Right. First function that we discussed is energy flow, right? And because of energy flow through trophic levels, there is a possibility of life on the Earth's surface, right? If energy is only concentrated with producers, it would be very difficult for the next trophic levels to sustain on the Earth's surface, right? So, because of energy flow, there is a possibility of diversity of life on the Earth's surface. Fine. So, that we discussed. Also, as a part of energy flow, we have discussed about pyramids, ecological pyramids, right? What are ecological pyramids? Ecological pyramids are the diagrammatic representation of energy flow, right? So, energy flows from producers, then primary consumers, then secondary consumers, and then tertiary consumers, right? So, that we can represent in the pyramidical form using trophic levels, fine. So, that we have discussed. Also, the types of ecological pyramids we have referred to. What are the different types of ecological pyramids? Pyramid of numbers, where we'll be representing the number of individuals of a species at a specific trophic level, right? So, that is pyramid of numbers, and pyramid of numbers can be both upright as well as inverted. It can be both upright as well as inverted, right? So, any terrestrial ecosystem you can take where you will be getting the pyramid of numbers as upright. But yesterday, while discussing this pyramid of numbers, I have referred to inverted pyramid of numbers as well, right? So, I'll be giving you another example to explain that. So, pyramid of numbers can be both upright as well as inverted. Pyramid of numbers can be both upright as well as inverted. So, upright is fine, So, let's say pyramid of numbers which is inverted. Let's say there is a tree, only one tree, right? On that tree, we will have various birds, let's say 20 birds, right? On the body of these birds, there will be various parasites, right? Let's say teaks, 100 teaks, fine. So, that is the pyramid of number which is inverted, where we have only one tree which is inhabited by 20 birds. On the body of 20 birds, we have teaks which are 100 in number, right? So that is pyramid of number which is inverted in shape, right? So that is first type of ecological pyramid. Second is pyramid of biomass, and we have also discussed that pyramid of biomass can be both upright as well as inverted. Inverted pyramid of biomass is found in aquatic ecosystem, right? In aquatic ecosystem, because the biomass of producers is very small, we can find pyramid of biomass inverted in aquatic ecosystem. And third type of pyramid that we discuss is pyramid of energy, right? It will always be upright. It can never be inverted, right? So that is important point as far as ecological pyramids are concerned. Pyramid of energy will always be upright. Fine. So that is about pyramid, ecological pyramids. Also, we have referred to two terms, bioaccumulation and bio magnification. So what is bioaccumulation? Bioaccumulation is accumulation of any toxic material from the external environment in the body of an organism, right? And increase in its concentration with time. Increase in its concentration of that toxic material with time. That is bioaccumulation. What is biomagnification? Biomagnification is increase in the concentration of toxic material as it is passed on from one trophic level to another trophic level, right? And to biomagnify, there are certain features also that these pollutants or toxic materials should exhibit so that they can increase their concentration through trophic level. Those characteristics are like, first, they should be fat soluble, they should not be water soluble. Next, they should be mobile, they should be stable, they should be biologically active as well, right? So those characteristics should be exhibited by these pollutants, right? So that we have discussed. Then we started discussing biogeochemical cycles. Biogeochemical cycles. Primarily, there are two types of biogeochemical cycles. First, gaseous cycle, and second, sedimentary cycle. So we started discussion of gaseous cycle, where we primarily discussed about water cycle, which is also called as hydrological cycle. Water cycle is also called as hydrological cycle. What are the processes involved in water cycle? Evaporation. One more word you may add there: evaporation and evapotranspiration. Transpiration, right? So evapotranspiration occurs through the leaves of plants, right? Where, let's say, during the exchange of gases, they open the stomata, and through stomata there is loss of water, and that loss of water is referred to as evapotranspiration, right? So that is the process involved in water cycle. Next, condensation. What happens in condensation? It is reverse of evaporation, right? In evaporation, there is conversion of liquid into gas. In condensation, there is conversion of gas into liquid, right? Then precipitation, right? And then percolation. These are the four important processes involved in water cycle or hydrological cycle. Then we discussed about carbon cycle as well. So what are the processes in carbon cycle? Right, respiration, photosynthesis, decomposition, combustion, volcanic eruption as well, right? So these are the processes through which the concentration of carbon dioxide increases or decreases in the Earth's atmosphere. Fine. Then we also referred to oxygen cycle, which is very similar to carbon cycle, right? It is the processes are almost same, right? Today we'll be discussing about nitrogen cycle, the most important cycle, the most important biogeochemical cycle. So, do we have nitrogen present in the Earth's atmosphere? Yes. Right? Almost 79% of the Earth's atmosphere or atmospheric gases, means 79% of the atmosphere consists of nitrogen. Right? So, it is there in the Earth's atmosphere. but this atmospheric form of nitrogen cannot be used by living beings, right? And that's why it needs to be converted into certain forms which are usable, which we can use to produce, or which we can use to produce, let's say, proteins or amino acids inside our body, right? Why nitrogen is needed? Because nitrogen is an important part of amino acid as well as proteins. Even you must be aware, the DNAs and RNAs, they also consist of nitrogenous bases, right? So that is why we need nitrogen. Not only we, even plants, other animals, microbes, they need nitrogen, fine. But the amount of, but the type of nitrogen present in the Earth's atmosphere is not useful for living beings, and that's why it need to be converted into usable forms, right? To convert atmospheric nitrogen into usable form, there is a process, it is called as nitrogen fixation. So first process involved in nitrogen cycle is nitrogen fixation. This nitrogen fixation occurs in two ways, right? There are two processes involved in nitrogen fixation, right? What is nitrogen fixation? Conversion of nitrogen, atmospheric nitrogen, into usable forms, right? So there are two processes or two events as a result of which there is conversion of nitrogen into usable form. First is, can you please tell me? Sorry? Fine, fine. That will be second. There are some natural processes, natural events like thundering, lightning. So using these, nitrogen is broken down. The atmospheric form of nitrogen is broken down and it is converted into ammonia. That means, see, there is a process, nitrogen which is present will be converted into its ions, and these ions of nitrogen will react with hydrogen to form ammonia, right? But reactions are not important from the exam's perspective. There is no previous year question where you will find the reactions that UPSC has asked. They have never asked the reactions, right? So even for general science, you should not focus much on reactions while reading, let's say, NCRTs. You should not focus much on reactions because they are not the part of our exam. You can go through previous year questions. You will not find questions on reactions, right? So through thundering and lightning, atmospheric nitrogen is converted into ammonia. Second process is bacterial processes. Right? Bacterial processes. Under bacterial processes, we have two types of bacteria which carry out this particular process. First is rhizobium, or we can say that symbiotic bacterias. Symbiotic bacterias like rhizobium. Right, symbiotic bacteria which are living in root nodules of leguminous plants, they fix nitrogen from the Earth's atmosphere, right? And that fixed nitrogen is in the form of ammonia, right? Second, freely living bacteria. Freely living bacteria are also there. Example, freely living bacteria. Azotobacter, right? Azotobacter. Even azotobacters are primarily found in the terrestrial ecosystem, but in aquatic ecosystem also we have freely living bacteria which help in the nitrogen fixation, and they are in the form of cyanobacteria. Like nostoc and also spirulina. spirulina or spirulina, right? So they are freely living bacteria which help in the fixation of nitrogen, right? Right. So that is, or these are the processes through which atmospheric nitrogen is converted into ammonia. Yes. Spirulina, NOSTOC. Right. So through these bacteria and through lightning and thunder, atmospheric nitrogen is converted into ammonia. Right. But problem is that not all living beings, not all plants can take ammonia. Right. There is a need of further conversion of ammonia into usable forms of nitrogen for other plants. Right. And that process is called as third process or second process through which the ammonia fixed by these processes is converted into nitrites and nitrates is called as nitrification. So second process is of nitrification. Right. So what happens in nitrification? In nitrification, ammonia is converted into nitrites or nitrates, right? And the bacteria involved in this process are Nitrosomonas, Nitrococcus and Nitrobacter as well, and Nitrobacter, right? Through these bacteria, ammonia is converted into nitrites or nitrates, right? Fine. So that is the process of nitrification. Fine. Now we have the nitrogen into the in the form of usable compounds. Now there will be assimilation. Third process is of assimilation. What is assimilation? Assimilation means use of nitrogen by living organisms, living beings to produce their, let's say, various compounds or various biochemicals like DNAs, RNAs, amino acids, proteins, etc., various hormones, etc. Right? So third process is assimilation. From external environment, it is assimilated into the body of living beings. Right? So that is the process of assimilation. Clear? So these are the processes through which what has happened, external nitrogen has been taken inside the body of living beings. Right? So now, yesterday while discussing energy flow, I have told you that the role of decomposers is very important. Right? So I am explaining that point now. So through these processes, what has happened? Through these processes, nitrogen which is present in the external environment is taken inside the body of living organisms, right? That means there will be fall in the concentration of nitrogen which is present in the external environment, right? Yes or no? There will be fall or not, because living organisms are assimilating that nitrogen inside their body. There will be fall in the concentration of nitrogen in the external environment. If we do not address this, or if there is no mechanism to ensure that this fall in the amount of nitrogen is restored back, then there may be a time, let's say thousands of years from now, there may be a time when we might not have nitrogen for organisms present at that particular time to use, right? And that's why the role of decomposers is very important. Fine. So now what has happened? From external environment, nitrogen is taken inside the body. Now it should be restored back as well. Now the processes that we'll be discussing are the processes through which it is sent into the external environment from the bodies of living beings. Fine. So first process involved in this is ammonification. ammonification. So what happens in ammonification? In ammonification, the excretory products, you must be aware, excretory products of living beings also include nitrogen bases. They also include nitrogen bases, right? So those, instead of saying nitrogen bases, nitrogen compounds, right? So those nitrogen compounds are converted into ammonia by the process of ammonification. And which are the bacteria which are involved in this particular process? It is Pseudomonas. It is Pseudomonas. Through these bacteria, the nitrogen compounds are converted into ammonia. Fine. So that is the first process through which we are ensuring that the nitrogen used by living beings is restored back, right? Next process. So here we have discussed about nitrification, conversion of ammonia into nitrites and nitrates. Now the nitrates are converted back into ammonia through the process of denitrification. Right. So it is the reverse of nitrification process that has led to conversion of ammonia into nitrites and nitrates, right? So it is the reverse. And what are the bacteria that carry out this particular process? It is Pseudomonas denitrificans. Pseudomonas denitrificans are the bacteria which ensure the conversion of nitrates back into ammonia. Clear? Fine, right? So these are the important processes involved in nitrogen fixation. Are we done with the processes, or any other process is there through which nitrogen can be made a part of the system of living beings? Is there any process? Is there any other process? First is nitrogen fixation, right, through which atmospheric nitrogen is converted into ammonia, right? And there are two processes for it: thundering and lightning, which are natural events, and bacterial processes, right? Second is nitrification, conversion of ammonia into nitrates and nitrites. Then assimilation, when these forms are there, living beings take up those forms of nitrogen into their body, which is called as assimilation. Assimilation of these nitrogen compounds into the body, and use of those compounds to produce various biochemicals. Then ammonification, it is conversion of the excretory matter of living beings into ammonia, right? And then denitrification. Denitrification is the process through which what we ensure? We ensure that nitrates are converted back into ammonia, right? One more process is there which influences nitrogen cycle, and that is the process of industrial fixation, right? So fixation ideally consists of natural processes as well as human induced or man-made process, right? So we'll write it separately as the sixth process. Sixth process is industrial process. Industrial process. So you must be aware there are nitrogen based fertilizers like urea, right? So what we do, at high pressure and high temperature conditions, we convert the atmospheric nitrogen into various kinds of compounds which are used in the fertilizers like urea, right? So industrial process, example, use of fertilizers. And that's why this year's question paper, where they have asked you about release of methane and nitrous oxide, which of the following crop leads to emission of methane and nitrous oxide? See, for many this question was confusing. Why? Because rice, often people know that rice cultivation leads to emission of methane, that they are aware of. But how nitrous oxide? That was the question. See, for cultivation of rice, do we use fertilizers or not? We use fertilizers, right? And when we are using fertilizers, let's say nitrogenous fertilizers, that will lead to emission of nitrous oxide. And that's why rice is or paddy cultivation is the right answer for that particular question. Methane is emitted naturally and nitrous oxides are emitted because of addition of fertilizers. Fine. So these are the processes through which nitrogen cycle works, and that's why I have said it is the most important process involved, or most important process or most important cycle under biogeochemical cycles. Fine? Yes.
In nitrification, there is atmospheric nitrogen
See, firstly it is ammonia. Then that ammonia at let's say external conditions, let's say temperature, high temperature, it is converted into nitrogen. Right? Atmospheric nitrogen is produced, but initially it is ammonia and then atmospheric nitrogen. Fine? Clear? Fine. So these are the processes, or these are the gaseous cycles. One more point related to gaseous cycle is that, see, whatever amount of nitrogen or whatever amount of gaseous nutrients are converted into the forms which are usable for living beings, all that amount is used by living beings. Right? Let's say if we want to put it in quantity, let's say 10 kilograms of nitrogen is fixed in the form of ammonia and then in the form of nitrates and nitrites. Then all that 10 kilograms of nitrogen will be used by living beings. It will not escape into the environment, right? And that's why these gaseous cycles are also called as perfect nutrient cycles. They are also called as perfect nutrient cycles. Why they are called as perfect nutrient cycles? Because the amount of gaseous nutrients converted in the usable forms for living beings, all that amount or almost all that amount is used by living beings, right? And that's why they are called as perfect nutrient cycles. This term you will understand more when we discuss sedimentary cycles. The next topic that we'll be discussing is sedimentary cycles. So we are done with gaseous cycles. Next is sedimentary cycles. Fine? A few new faces are there. Have you read Environment and Ecology earlier? You have read. Have you read? Apthekal? So, have you read Environment and Ecology earlier? You were there? Okay. Have you read? You have studied it. Okay, fine. Have you attempted prelims earlier? This will be first attempt. Fine. Yours? Second. Okay. Sorry? Not yet. Fine. See, you must be aware, these are revision classes, right? And that's why we are supposed to go in a very fast manner. We have to cover all the topics, and that's why we'll have to rush through the topics. Fine. So I hope you understand, because otherwise in foundation, these classes, means especially environmental ecology part, this part, I dictate as well, right? Almost 7 to 8 classes are dedicated for that. But here we have to cover environment and ecology the way it is given to you in the brochure of this particular target PT program, right? And that's why we'll be rushing through these topics, right? And that's why I expect that you must have read it. Otherwise, it would be difficult for you to understand this subject, fine? And see, what is the benefit of a weekend batch? Let's say from tomorrow you'll have off for 5 days. Then you will be writing test again on Saturday, right? So meanwhile, you should read the topics on which exam is supposed to be conducted, so that it will not only help you to answer questions in that particular test, but also it will help in the revision classes, right? Because if you have read those topics, then it will help you understand those topics in a better way in the classroom. Right? If you are studying environment and ecology for the first time through these classes, it would be it would give you idea, but it would be very difficult for you to keep those ideas or to link those ideas with that with, let's say, the topics that you are supposed to read, right? Because if you have read it, you will have certain idea in your mind, and you will through these discussions you will get, okay, this is linked to the part that I have studied. But if you have not read environment and ecology, it would be slightly difficult for you, because as you are aware, in 6 days we will be covering environment and ecology, because you have 6 tests of environment and ecology. So in 6 days we are supposed to cover environment and ecology, and that's why these are revision classes. Clear? So whenever you come to the class, make sure that you are reading the topics mentioned in the brochure. For example, today the test was on biodiversity, right? So towards the end we'll be starting biodiversity as well, right? So that is about gaseous cycle. Then sedimentary cycles. Why they are called as sedimentary cycles? Right, because those nutrients which are cycled in this particular cycle are present in the Earth's crust. They are present in the Earth's crust, right? They are not present in the atmosphere, they are primarily present in the Earth's crust, and that's why they are called as sedimentary cycle, right? So there are two important sedimentary cycles: phosphorus and sulfur cycle. Phosphorus cycle and sulfur cycle. Fine. So you must be aware, phosphorus is present in the Earth's crust in the form of phosphate rocks, right? So firstly we are discussing phosphorus cycle. So phosphorus cycle starts with phosphate rocks which are present in the Earth's crust. These phosphate rocks, they undergo certain processes, physical processes obviously, like weathering, or instead of saying physical processes, geographical processes, weathering and erosion, because in weathering we have physical weathering, chemical weathering as well, right? So it is better to say geographical processes like weathering and erosion. So through weathering and erosion, phosphorus gets mixed with soil and water. It gets mixed with soil and water, right? Now as it is mixing with soil as well as water, part of the phosphorus is lost, right? Part of the phosphorus which got mixed with water gets lost. It is not usable, or it is not useful for the living organisms, right? So it is lost in oceans. And if it is if we are losing this phosphorus in the form of phosphorus added to oceans, can you please tell me what it will contribute to? This phosphorus which is lost to oceans, what it will contribute to? It will contribute to form sedimentary rocks. It will contribute to form sedimentary rocks, because you must be aware, most of the sedimentary rocks are present in the water bodies, right? So the lost phosphorus will be lost to oceans in the form of sedimentary rocks, right? And those sedimentary rocks, as they are present in ocean, they will not undergo weathering and erosion process as of now. When they are exposed to various factors of weathering and erosion, then only they will undergo that process through which phosphorus will be released again, right? And that's why we are saying that part of phosphorus is lost, right? And that's why these sedimentary cycles are called as imperfect, imperfect cycles. They are called as imperfect cycles. Why they are called as imperfect cycles? Because the part of nutrient which was present in the form of sediments is lost to the oceans and it becomes a part of sedimentary rocks, right? And those sedimentary rocks, they are present in the water body, they are not undergoing any weathering and erosion, and that's why the phosphorus stored in those sedimentary rocks remains unavailable for living beings, right? And that's why they are called as imperfect cycles. Clear this term, perfect and imperfect, and that's why we call gaseous cycles as perfect cycles, because most of the amounts of gaseous nutrients are available for the living beings. Clear? So that is how phosphorus is mixed with soil as well as water. After this, there will be assimilation. Assimilation. Firstly, assimilation will happen with or in plants. From plants, it will be transferred towards consumers, and from plants and consumers, it will be transferred towards decomposers, who will make sure that the phosphorus is added back to the phosphate rocks, or it is added back to the external environment, right? So that completes the phosphorus cycle. Clear? Right? So what happens in phosphorus cycle? We have phosphate rocks present in the external environment. Those phosphate rocks undergo the processes called as weathering and erosion. As a result of that, phosphorus is added to soil and water. Part of this phosphorus is lost to oceans and it remains unavailable for the utilization. But the remaining part will be assimilated primarily in the producers or plants. Then from producers, it will be transferred towards consumers, and from producers and consumers, it will be transferred towards decomposers, who will decompose the dead organic matter to ensure that phosphorus is released back to the external environment, right? So that is how the phosphate cycle or phosphorus cycle works. Clear? Clear? Second cycle is, or second nutrient cycle is, sedimentary nutrient cycle is sulfur cycle. Sulfur cycle, right? Now, sulfur cycle, it is not exactly sedimentary cycle, right? Because there are two phases of sulfur cycle. There are two phases of sulfur cycle. First is sedimentary phase of sulfur cycle, which is quite similar to the phosphorus cycle, right? So there are two phases. First is sedimentary phase. Sedimentary phase, where we have sulfate rocks which undergo weathering and erosion. From that, sulfur is added to the soil and water. Part of it is lost. Part of it is lost to oceans, right? Then assimilation will happen. Assimilation will happen in firstly in producers and then in consumers. Then after assimilation, there will be the role of decomposers, who will add this sulfur back to the environment, external environment, right? You may again write assimilation in producers, then consumers, and from both, decomposers will make sure that sulfur is added back to the sulfate rocks. Fine. So that is the sedimentary phase of sulfur cycle, which is quite similar to the phosphate cycle, right? But apart from this sedimentary phase of sulfur cycle, there is gaseous phase as well. Do we have sulfur present in the atmosphere? Yes, we have, right? So gaseous phase. So what are the cycles or what are the processes involved in the gaseous phase of sulfur? Exactly. So there are two processes, natural and human induced. Two processes. Natural process, we know that the most important gas emitted through volcanic eruptions is sulfur dioxide, right? So volcanic eruptions. Volcanic eruptions, right? Human induced processes primarily include use of fossil fuels in industries as well as in transportation, right? So use of fossil fuels. Use of fossil fuels. Fine. So through these processes, we make sure that the sulfur dioxide or the sulfur is added to the external environment. So let's say through natural processes like volcanic eruption, sulfur dioxide is added to the atmosphere. Now, if in association with that, let's say the nitrogen oxides are also present in the atmosphere, so they will react with the rainwater, right, and eventually they will contribute or they will come down in the form of acid rain, right. So we have not discussed acid rain. Acid rain is the process through which atmospheric sulfur is added back to the soil, and through soil it will be utilized by primarily plants, then it will be transferred towards consumers, and through both these it will be given back to decomposers, right. So that process we have cut short here, right. I hope through you understand what happens next. Through these processes, sulfur dioxide is added to the atmosphere. That sulfur dioxide reacts with rainwater, lead to formation of acid rain along with nitrous oxides, right, and that acid rain, it falls back on the earth's surface, and as it falls back on the earth's surface, sulfur is added to the soil, through which it is used by producers firstly. Through producers it will be transferred to consumers, and from producers to consumers to decomposers, right. So that is how these cycles work. Clear? So that is about the biogeochemical cycles or nutrient cycles. So most important cycle is nitrogen cycle, right. You may add a few plant names in nitrogen cycle. Please come back to nitrogen cycle. You may add the name of plants. So you must have written about the symbiotic bacteria like rhizobium, right. So symbiotic bacteria, they live in association with leguminous plants, right. So examples of those plants, example, yes, cowpea, 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 soybean, peanut, alfalfa, ALFA, alfalfa, acacia, ACACIA, acacia. Next, clover, 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 and sea berry, SEAC berry, BERRY. Fine. So UPSC asked question on these plants as well. This year there was a question, which of the following plants are involved in nitrogen fixation? Fine. So that is about nutrient cycles, and that is about the second function of biogeochemical cycle. Next is ecological succession. Ecological succession. Let me ask you a question. We have discussed that there are two components of the environment. They are biotic and abiotic. Biotic and abiotic components, right? So, abiotic components, that means non-living components, are they constant? Abiotic components like, let's say, sunlight, water, rainfall, atmospheric gases, their concentration, it changes or remains constant. It keeps on changing, right? Availability of rainfall in a certain location, it will differ, right? If rainfall is differing, then availability of water will also differ, right? The soil conditions will also differ, right? So, as abiotic components keep on changing, can we say biotic components also keep on changing? Yes. Right? So, we have discussed that yesterday we discussed that there is constant interaction between abiotic and biotic components, right? So, as there is a constant interaction, if there is change in abiotic components, it will have its influence on the biotic components as well, right? Biotic components also keep on changing, right? So, this change in the structure of a community where there is change in the composition of different species living in that community is called as ecological succession, right? Ecological succession is change in the composition of species of a community, right? So, that is called as ecological succession, and that ensures that there is evolution. Ecological succession ensures that there is evolution, there is change in the pattern of species in a particular ecosystem as a result of change in the abiotic components, because abiotic components will keep on changing, and to ensure that life remains even if abiotic components change, there is a need of change in the structure of species as well, and that change in the structure composition of species is called as ecological succession. Fine. Primarily, there are two types of, you may write the definition of ecological succession. Definition: the process by which communities of plant and animal species, the process by which communities of plant and animal species in an area are changed or replaced over a period of time is known as ecological succession. Fine, right? So, primarily there are two types of ecological succession: primary ecological succession and secondary ecological succession. So, two types. Primary ecological succession and secondary ecological succession. So, what happens in primary and secondary ecological succession? What makes them different? Primary ecological succession, it is a kind of ecological succession. That means it is a kind of change in the species composition which occurs in a barren or lifeless habitat, right? Primary ecological succession occurs on a barren or lifeless habitat, right? It occurs in a barren or lifeless habitat. Let's say initially there was only a barren rock in a particular location. Initially there was only a barren rock, but as there was a change in the conditions, climatic conditions, barren rock gave, or it led to formation of, let's say, some kind of soil. Then on this soil, as conditions became bit favorable, let's say lichens occurred. Lichens initially on soil, conditions became favorable, and as a result of those favorable conditions, what occurred? Lichens, right? See, conditions are not very favorable, but conditions are bit favorable than earlier, and that's why initially lichens occurred in that particular location. Now these lichens, they released various kinds of nutrients, right? And as a result of the addition of nutrients to soil, we can say that, let's say, some primary plants occurred. Some kind of primary plants occurred, right? These plants again made conditions favorable for various types of life to evolve, and finally we may have a thriving ecosystem which is called as Climax Community, right? So this is the change in the composition of a particular ecosystem, right? So initially we only had a barren rock structure. That barren rock structure was disintegrated, and that led to formation of soil eventually. See, this process occurs over thousands of years. It is, though we have discussed in less than 2 minutes, it occurs over thousands of years, right? So from barren rocks, soil was formed. On soil, conditions were bit favorable, as a result of which lichens occurred initially. Then lichens made conditions again favorable for primary plants to occur. Those lichens, primary plants, made conditions even favorable for a climax community to occur in this particular region, right? So this is how ecological succession works in a primary ecological succession, right? This first evolution, life form that occurred in this particular lifeless habitat is called as pioneer species. The life form which occurs firstly in a lifeless habitat is called as pioneer species, right? So in this case, lichens are pioneer species. Fine. The stages from pioneer species to climax community, the stages that occur between pioneer species to climax community are called as serrae. They are called as serrae, right? All the stages between pioneer species to climax community are called as serrae. One individual stage, let's say a stage of primary plants, right? One individual stage in the ecological succession is called as serral, right? Serral is one specific or one individual stage in the ecological succession. All the stages in ecological succession, they are called as serrae. One individual stage is called as serral. Fine. So 4 terms you should be aware of in ecological succession. First is pioneer species. What are pioneer species? Pioneer species are those species which occur in a particular habitat for the first time, right? That habitat was undergoing change, and when first species occur in a particular habitat as a result of ecological succession, it is called as pioneer species, right? Second term is serrae. Serrae, the stages between pioneer species to climax community. The stages between pioneer species to climax community are called as serrae. Third is serral. Individual stage in the ecological succession is serral. And fourth term is climax community. Climax community, right? So when we use this word community, what we are referring to? Right. So yesterday we have talked about ecological levels, where we have already discussed community. So community consists of group of different species, right? So climax community is a type of community. That means it is a type of, it is a group of different species where we can say for a time being stability has occurred. For a time being only. That stability will also disturb, will also change eventually. But for a time being, we can say that, okay, this is the thriving community where a certain kind of stability is seen. So that community is called as climax community. Climax community also, though name is climax, climax community also lead to new community as well, right? It is the intermediate stage only. It is like a serral only. Fine? Climax community is also a kind of serral, because as conditions change in that particular climax community, the species composition will also change. Fine? So that is primary succession which occurs on a barren or lifeless habitat. Let me ask you a question. Can we see primary ecological succession on the Earth's surface now? It is very difficult. It is very difficult because it would be very hard to find out a place where life do not exist, right? And that's why primary succession, to get the evidences of primary succession is very difficult as of now, because many places on the Earth's surface, they have the presence of life, right? And condition for primary succession to occur is that barren or lifeless habitat should be there. Fine. So that is primary succession. Second is secondary succession. Secondary succession, right? Let's say a climax community has reached, right? Climax community has occurred in this particular habitat. Now, let's say some kind of natural event occurs. Let's say volcanic eruption, and as a result of volcanic eruption, this climax community ends. It is instead of saying ends, it is destructed. It is destructed, right? So climax community was there, but because of natural events like volcanic eruptions, droughts, cyclones, any such natural event, it got destructed, and all the life forms in that particular habitat are wiped out, right? Now again there is no life in that particular habitat. When life starts again in that particular habitat, where because of certain natural event or because of certain human induced factor, life got destructed, when life starts again in that habitat where it was destructed, that kind of succession is secondary succession, right? Secondary succession is a type of succession. It is a type of ecological succession which occurs on a habitat where earlier life was existing. Earlier life was there, but it got destructed because of the actions natural actions like cyclones, volcanic eruptions, droughts, floods, or human induced actions like, let's say, pollution, introduction of invasive species, climate change, etc. Fine. So that is called as secondary ecological succession because it is occurring on such a habitat where life was there earlier. Fine. And one major point of difference between primary and secondary ecological succession is that secondary ecological succession is faster than primary ecological succession, right? Why it is faster? Because conditions are not like this. Conditions are not like this. Conditions are already favorable for the life, right? And then when life starts on that habitat again, it will be faster process compared to primary succession. Fine. So these two are the important types. But apart from these two types, there are some other types as well, like autogenic and allogenic succession. Because see, you must be aware, do you follow the Hindus YouTube channel? Do you follow? Okay, have you seen recently, that means almost 3 to 4 months back, there was one video on Senna spectabilis. Senna spectabilis. So what are Senna spectabilis? They are a kind of invasive plant species occurring in Nilgiri Biosphere Reserve. In Nilgiri Biosphere Reserve, we have an invasive species called as Senna spectabilis. And that Senna spectabilis, it is said, it is using up 70% of the resources which are actually meant for the local habitat, the local species, right? So if that is the case, if all these resources are being used by Senna spectabilis, eventually the original species will be wiped out because they won't be able to get access to the resources, right? So that is also a reason because of which we may face damage or destruction to the ecosystem. Fine. So coming back to this autogenic and allogenic succession. What is autogenic succession? Right. Yes. Right. So autogenic succession is the kind of ecological succession. See what we have discussed. We have discussed primary and secondary. We can say that autogenic and allogenic successions are type of secondary ecological succession, right? Why we are saying that? Because autogenic ecological succession is induced by the life present in that ecosystem only. It is induced, it is started by the life or biotic components present in that habitat at the first place, right? That means they will carry out certain processes which will lead to destruction of the original life, right? The biotic components of the habitat will carry out certain processes which will lead to destruction of original life, and that destruction will again lead to formation of different life on that particular habitat, right? So what has happened? See what we have discussed here. Climax community has reached, right? After climax community, there should be destruction. So this destruction, if it is induced by the biotic components themselves, then that is called as autogenic succession. If destruction of primary climax community is induced by the biotic components of that particular community, it is called as autogenic succession. Auto means by themselves, right? On the other hand, allogenic succession is a kind of secondary succession where destruction is by external factors. It is by external factors, right? So autogenic and allogenic successions are the types of secondary ecological successions. In autogenic succession, destruction is because of the biotic components present in that ecosystem only. On the other hand, in allogenic succession, it is induced by external forces. Right? Clear? Hayana? Fine. Autogenic and allogenic. Name itself tells you, autogenic, it is induced by themselves. Right? Allogenic, it is the result of external factors. Fine. One more type is there of ecological succession. It is hydrarch and xerarch succession. Hydrarch and xerarch succession. What happens in hydrarch and xerarch succession? See, hydrarch succession is a kind of succession which occurs in wetter habitat. It occurs in wet regions. It occurs in wet regions. On the other hand, xerarch succession occurs in drier conditions or in drier regions. Right? So, what will be the end result? End result will be, yes, what will be the end result? See, sorry? Yes, see, here let us say on my right hand we have hydric conditions, we have wetter conditions, and on my left we have, let us say, drier conditions. When hydrarch and xerarch succession occur, they come somewhere in between. Right? So, hydric conditions are converted into mesic conditions. Right? Here, hydric to mesic conditions. Right? And here, from xeric to mesic conditions. From xeric to mesic conditions. Fine. So, hydric to mesic, xeric to mesic. Right. So, somewhere in between they reach, and from that they ensure that life starts evolving. Clear? Hydrarch and xerarch succession are the successions which occur in wetter and drier regions respectively. When this kind of succession occurs, there will be change in the habitat conditions. In hydrarch succession, conditions will change from hydric to mesic, and in xerarch succession, conditions will change from xeric to mesic. Fine. So, that is about ecological succession. So, what is ecological succession? It is change in the composition of species. Now, one more point related to hydrarch and xerarch. See, initially there were some species which were used to hydric conditions, and initially there were some species which were used to xeric conditions. As habitat conditions change, will they remain in those habitats? They won't be able to sustain in those habitats because their habitat condition is changing. Let me give you an example. You must have heard about bushfires of Australia, right? I think primarily they occurred in 2020, early days of 2020, right? So, as a result of those bushfires, there was destruction of eucalyptus forest, which is a home of kangaroos and koalas primarily, right? So, koalas, they depend on those eucalyptus forest for their life processes. If it is destructed because of bushfire, these koalas, they are compelled to migrate in other regions, right? In other regions, when they are going, those regions might not be very helpful. Those conditions, those newer habitat conditions might not be very helpful for koalas. And that's why there may be a chance that these koalas won't be able to sustain in their new habitat, right? Same is the condition here. If conditions of habitat are changing from hydric to mesic and from xeric to mesic, the organisms which were there initially might not survive in the mesic conditions. Fine, and that's why there is change in the species composition, which is what ecological succession is. Clear? Fine? Clear? Next. Next is last function, homeostasis. Homeostasis. Have you heard about this term? Yes. What is homeostasis?
Maintaining internal temperature instead of changing the external temperature.
Homeostasis. See, homeostasis is the condition which is not only exhibited by ecosystem, because we are discussing this term in the context of ecosystem. It is also exhibited by various organisms, right? Even we human beings exhibit homeostasis. What is homeostasis? Homeostasis is to regulate your internal environment. That means to maintain your equilibrium despite the changes in external environment. That is what homeostasis is. For example, human beings, our body temperature is 37 degrees Celsius. But despite extremely hot summers, let's say a few days back we had temperature almost going around 45 degrees Celsius. But despite that kind of temperature, we survive. Why? Because we have ACs. Is it the case? No, that is not the case, right? It is because of sweating we can sustain that kind of temperature. When temperatures are high, we sweat. And you must be aware, when sweat gets evaporated, there will be a cooling effect. There will be a cooling effect, right? When sweat evaporates, there will be a cooling effect, and that helps our body to cool down to 37 degrees Celsius, right? So that is first. That is first, the homeostasis which occurs during summers. When winters occur, let's say in few months, we'll be witnessing temperatures which will be as less as 5 degrees Celsius. At that time also we are able to maintain our body temperatures because of shivering. We shiver, right? And shivering is a kind of movement. It is a kind of movement which leads to creation of energy, and that energy helps us to maintain body temperature at 37 degrees Celsius, right? So that is what is homeostasis. Because of these activities, sweating and shivering, we have maintained our body temperature at 37 degrees Celsius, right? That means we have maintained our equilibrium. As human beings or other living beings are able to showcase this kind of adaptability, this kind of property of homeostasis, even ecosystem have the property of homeostasis, right? So what is homeostasis of an ecosystem? Let me explain this with the help of example. So yesterday we discussed about, let's say, ecological pyramids. Let's say this is ecological pyramid where we have grasses at the first trophic level, followed by grasshoppers which feed on grasses, right? Then grasshoppers are feeded upon by, let's say, frogs, right? And then let's say snakes. So this is a food chain. We have grasses, then grasses are feeded upon by grasshoppers, then frogs and snakes. You must be aware, in 2020, during 2020 early lockdown period, we witnessed locust attack, right? We witnessed locust attack, and locusts are nothing but a kind of grasshoppers, right? So as a result of the locust attack, let's say the number of grasshoppers increased. Number of grasshoppers increased as a result of the locust attack. So what will happen? See, number of grasshoppers has increased, but not the food available for them. And that's why eventually these additional number of grasshoppers, they will die. And this is what is homeostasis is. It is the ability of any ecosystem to maintain its equilibrium, through self-regulation, right? So homeostasis is ability to maintain equilibrium through self-regulation. Fine? But see, this ability, this homeostatic ability of any ecosystem, will it be finite or infinite? Homeostatic ability of an ecosystem, will it be finite or infinite? It will be finite, right? It will be finite. If we have such conditions, if we, let's say, introduce invasive alien species in a particular habitat which are using up the resources, in the initial stage, the ecosystem will try to maintain its equilibrium. But if the attack is severe, ecosystem won't be able to maintain its equilibrium, right? So the homeostatic ability of any ecosystem is limited. It is finite, right? And that's why we are witnessing the ecosystem destruction in the external environment, right? Because of the introduction of, let's say, pollutants, conditions of air or conditions of, let's say, water ecosystem is changing. So that is because homeostatic ability is limited. Clear? Fine. So what is homeostasis? Homeostasis is the ability of any ecosystem to maintain its equilibrium through self-regulation. It is a finite ability of any ecosystem, right? So that is about various functions related to ecosystem. Clear? So under ecosystem, what we have discussed? We have discussed primarily the structure of ecosystem and functions of ecosystem, right? See, there are various types of ecosystems as well. For example, we have forest ecosystem. Primarily, there are two types of ecosystem: natural and man-made or human-induced or anthropogenic ecosystem, right? Natural ecosystem consists of forest ecosystem, aquatic ecosystem, desert ecosystem, grassland ecosystem, etc. And man-made or anthropogenic ecosystem includes crop ecosystem. Crop ecosystem is our own creation. Aquarium, it is also an ecosystem that we have created. Fine. But when you read any book, you will find that the term ecosystem and the term biome that we will be discussing now, they are used interchangeably. Right? And that's why the types of ecosystem will be discussing under biomes. Fine. So that is about ecosystem. Types will be discussing under biomes. Clear? Next topic, fifth level of ecological organization. We have discussed fourth level just now, ecosystem. The fifth level is biomes. Fifth level is of biomes, and the most important topic under environmental ecology, biomes. Biomes. So we have defined biomes yesterday. Can you please tell me what do you mean by biomes? Anyone with geography option? पहले था क्या? Commerce? अच्छा, geography. Yes. Biomes. Fine.
A particular type of vegetation in a particular area of space.
Fine. Right. See, yes, most of the aspects you have touched. See, biomes, they are related to a type of vegetation present in a particular ecosystem. Often, we associate biomes with a type of vegetation present in an ecosystem, right? But as vegetation is present, obviously there will be fauna or animal species present, right? But our focus is not on those animal species as far as biomes are concerned. It is primarily the vegetation present in a particular ecosystem, in a particular region, right? And when we are talking about vegetation, we know that vegetation is influenced by certain conditions like climatic conditions, right? Also edaphic factors influence the type of vegetation present in a particular region. Edaphic factors. What are edaphic factors? Edaphic factors, soil, right? So, biomes which are a type of vegetation present in a particular region influenced by climatic conditions and edaphic factor. See, edaphic factor is nothing but soil conditions, and we know that climate is a prime determinant of the type of soil present in a particular ecosystem, right? And that's why we can say that biomes are a type of biomes are a region which are primarily influenced by certain type of vegetation whose characteristics are determined by the climatic conditions, right? We can avoid edaphic factors because climatic conditions are the prime influences of edaphic factors as well. Fine. So, what are biomes? Biomes are a larger ecological unit. They are a larger region influenced by or whose characteristics are determined by the type of vegetation present in a particular region, right? And when we say vegetation, we know that vegetation is determined by the climatic conditions, right? So, you may write the definition of biomes. Biomes under that, a biome is a complex of communities. A complex of communities. And when we are writing community, we are writing it in the context of ecology, right? It is a complex of communities, right? That means a group of different species. It is a group of different species maintained by the climate of the region, maintained by the climate of a region, and characterized by a distinctive type of vegetation. Distinctive type of vegetation. Next point. The biome is not based on the species of plants and animals present, but rather it is based on the life form of the most important plants. The life form of the most important plants that gives the landscape its special characteristic. Fine, right? So that is how biomes are defined. It is defined based upon a certain type of plant species which is dominant, or that plant species is determining the characteristics of that biome, right? And that's why the names, let's say forest ecosystem or under forest equatorial rainforest, deciduous forest, right, coniferous forest, desert, grassland, right. So these names are influenced by the type of plant species present in that region. Fine. Now we have discussed that, or we have written that the characteristics of biomes are influenced by climatic conditions. And when we talk about climatic conditions, we are referring to two prime climatic conditions. What are they? Temperature and precipitation. So two factors that influence biomes are sunlight, which influence the temperature of a region, and precipitation. Right? So these are the two key determinants of the climatic conditions, which in turn determine the type of vegetation present in a particular region. Clear? Clear? Right? So as for sunlight, firstly, see, for sunlight we can give a thumb rule, or there is a thumb rule for sunlight. Increase in the sign of latitudes, sunlight goes on decreasing, right? So that is a thumb rule. Increase in the sign of latitude, sunlight goes on decreasing. For precipitation, though it is not a thumb rule, in general we can say increase in the sign of latitude, precipitation goes on decreasing. Precipitation, when we are referring to precipitation, we are primarily talking about precipitation in the form of rainfall. Precipitation in the form of rainfall, right? So sunlight, increase the sign of latitude, sunlight goes on decreasing, availability of sunlight goes on decreasing. For precipitation, generally increase the sign of latitude, precipitation goes on decreasing. And as a result of this, we have different life forms, different plant species in different locations of the Earth's surface, right? Now we'll be discussing about types, where we'll be covering different types of biomes as well. For example, let's say this is equator. Fine. Let's say this is equator, this is 10 degree north, this is 30 degree north. Then we have 45 degree north, 60 degree north, 70 degree north, and then 80 degree north. Right? First type of biome that we'll be discussing is Tundra biome. First type is Tundra biome. So, see, these biomes are determined as a result of climatic conditions. And you must be aware, tundra is a kind of biome which is present at the latitude of 70 to 80 degree north. 70 to 80 degree north we have tundra biome, right? So first point you may write location, please write simultaneously. Location 70 to 80 degree north latitudes. 70 to 80 degree north latitudes, right? So that is the location. What are the conditions there? Conditions, right? So surplus precipitation in the form of snowfall, surplus precipitation, but deficit sunlight. Surplus precipitation, deficit sunlight is the prime condition of tundra biome, right? Then what are the features of it? Features. See, the most important feature of tundra biome is that its subsurface remains permanently frozen. I'll explain this. First feature is permanently frozen subsurface. Permanently frozen subsurface. What is that? See, subsurface means the layer below the top layer, right? Let us consider this is permafrost. Permafrost means permanently frozen ice or surface, right? So, as a result of availability of sunlight during summer season in this location, this top layer of ice will melt. But that is only the feature of top layer. The subsurface remains permanently frozen, right? Subsurface remains permanently frozen. Only the top layer melts because of the availability of sunlight during summer season. Why summer season we have availability of sunlight at this particular location? Why not in winter? Because in geography you must be aware there is apparent movement of sun towards north for summer seasons for northern hemisphere, right? Whenever in the northern hemisphere we have summer season, there is apparent movement of sun towards north, and because of that apparent movement of sun towards north, we have availability of sunlight in the tundra biome, and that leads to melting up of upper layer of ice, but subsurface remains permanently frozen, right? So that is the feature. So as subsurface is permanently frozen and as upper layer is melting during summer season, we have waterlogged conditions during summer season. So second feature is waterlogged conditions. Yes or no? Waterlogged conditions during summer season. Fine. So when, see, life will occur in which region? Where we have harsh conditions or where we have conditions bit favorable? Obviously, right? Obviously, when conditions are bit favorable, life will occur there, right? So when waterlogged conditions are there in the tundra region during summer season, we'll be able to find vegetation in this particular location, right? So not vegetation, life, instead of vegetation, life, right? So life will occur in tundra region when waterlogged conditions will occur there, and when waterlogged conditions are occurring during summer season for northern hemisphere, right? Next, species. What kind of species do we find in the tundra region? Firstly, vegetation. So we have mosses and lichens in this particular region, right? Species, mosses and lichens. Mosses and lichens. And this was the question that UPSC asked in, I think, 2021's prelims examination. Which of the following organisms can grow without soil? Right? So that's why it is, see, the material that you will be reading or the classes that you will be attending, they will provide the knowledge, right? They will provide the information to you. You'll have to apply that information to solve questions, right? Hardly there will be a book which will be talking about the plants or the organisms which can grow without soil, right? But these kind of things will be there. Let's say mosses and lichens, they grow in the locations where we have permanently frozen subsurface. That should click in your mind. Okay, mosses and lichens can grow without soil because they are growing on the permanently frozen subsurface. So that is the application of knowledge, that is the demand of this exam. Hardly you will find questions which are very straightforward. That means you have read something and you are able to address the question using that information. very few questions, right? It is more about application, right? And that's why it is important to learn this application, and that's why these test series practices are important for that, right? It is important to use these test series to learn the application of knowledge that you have. Fine. And one more, today you have written second test, yesterday first test. So how many questions you have attempted? Sorry? Out of 50, around 30 questions. Okay. Any other? Sorry? 18. Fine. 26. 42. 42. Okay. See, fine. See, these are the tests where you should experiment. Where you should experiment. Right? Let's say in initial few tests, you are solving only those questions which you are aware of. Right? That means, let's say 20 questions, 25 questions, whichever is the number of questions you are aware of, only solve those many questions and track what happens. There must be the results, right? You must be getting results and ranks. Sorry? On portal. Fine, fine. On portal you must be getting ranks and all. Right? So, see, you will have to keep a separate sheet. Test number 1, I have attempted these many questions, correct questions these many, incorrect these many, rank, marks and then rank. So that kind of sheet you should maintain and analyze what happens. In first 5 papers, you are attempting only those questions which you are aware of. In next 5 papers, let's say you are solving those questions where you have eliminated 1 or 2 options. Right? That means, see, elimination, though they have targeted elimination in last prelims, elimination is the method which you will have to use to solve objective questions. Right? It will not go anywhere. Though they have targeted a few questions, fine. See, they will do that. But it would be difficult for them to ask such type of questions, it would be difficult for them to ask more questions which are where you are not able to use elimination. Right? How many questions were there where you could not use elimination last prelims? 8 or 10 questions were there. Fine, but it is not only for you. It is for all the aspirants. Right? So don't think that okay, UPSC has used such questions, has asked such questions where elimination was not useful. Fine, they will do that. They also carry out their own market research and they also try to address those issues which are helping aspirants get good marks. Right? So that is one of the methods where they targeted elimination method. But elimination will not go. It will remain there. Right? 8 to 10 questions, that means let's say 90 to 92 questions were there where you were able to use elimination method. Fine. So in first 5 tests, you have solved only those questions which you are aware of. In next 5 tests, solve those questions where you are able to eliminate 1 or 2 options and analyze what happens. See, no one will analyze for you. It is you who will have to analyze for yourself. Analyze what happens. Your score increases or not. Right? Your rank is improving or not. See, you should not take these scores or ranks very seriously. Right? They should have very limited value in your preparation. You should not get disheartened or you should not feel, okay, I am the only one. Right? That should not be the case. Right? So these tests are for ensuring that you are able to finalize the strategy which you will be using in the final paper. They are not for marks. Right? Marks, yes, means you should not score very low. If it is consistently low, then you will have to address that problem as well. But you should not be disheartened by these kind of marks that you may get, or you should not be very confident after the test results. Right? You should use these tests to finalize your strategy. What kind of strategy you will be following in the prelims examination? You will be going for elimination method or not, because elimination method does not work for all. It does not work for all. You will have to find out whether it works for you or not. And it is these tests which will help you find out whether it works for you or not. Right? And that's why you will have to maintain a sheet where you are writing how many questions I have attempted, how many correct, incorrect, scores, rank. Right? That way you will have to analyze yourself, and you should mention there where I have used elimination, where I have not used elimination, so that you are able to come up with a strategy which you will finalize, which you will practice throughout the test series, throughout the further tests, and then you will be able to use it in the final exam. Fine. So such kind of questions you should be able to mark from these kind of discussions that we are having. Clear? So mosses and lichens primarily occur in this particular region. Also, we have insects. We have insects in this region because of the waterlogged condition. We have insects as well. Also, it is this region where we have the migratory adaptability of, let's say, polar bear. Fine, Siberian crane as well. Siberian crane as well. Polar bear, Siberian crane. Right, so these kind of animals we are able to see in the tundra biome. Even Arctic fox, reindeer, Arctic fox, reindeer, these kind of animals are also seen in the tundra biome, right? But they exhibit migratory adaptability. Whenever winters occur in the tundra biome, they will migrate to lower latitudes, right? Only during summer, when these kind of vegetation occur in the tundra biome, they go to the tundra biome. Otherwise, they are there in this particular latitude of 60 to 70 degree north. Fine. So they exhibit migratory adaptability. Clear? Fine. So that is tundra biome, the most important biome, or the biome which is present at the 70 to 80 degree north latitudes. One more point. Do we have tundra biome in the southern hemisphere? We do not have tundra biome in the southern hemisphere. Why? Because the extent, the latitudes at which it is existing in north hemisphere, those latitudes are water in southern hemisphere, and that's why tundra biome is available only in northern hemisphere. It is available only in northern hemisphere. Fine. One more point you may add here in species. Reptiles and amphibians are almost absent. Reptiles and amphibians are almost absent. Fine. So as tundra biomes are present in this particular latitude, 70 to 80 degree, they are also called as Arctic tundra. They are also called as Arctic tundra. Right? One more term you must have heard. It is Alpine tundra. Yes or no? Alpine tundra. So what are Alpine tundra? Can you please tell me? They are the tundra biomes, but not in this particular latitude. They are present at the peaks of mountains. Let's say Himalayas. In Himalayas, we have conditions which are similar to tundra biome at the peaks of those mountains. Right? So tundra biome, its prime location is 70 to 80 degree north, but apart from this location, there is second location where we have Alpine tundra. Right, where at the mountain peaks. Clear? Next, second biome that we'll be discussing is desert biome. So that was first tundra, second is desert. Second is desert biome. So again, location. Firstly, we'll discuss about the location of desert. So where do we have desert biomes? See, primarily two locations. Primarily two locations. First, this 10 to 30 degree north and south western margins of the continent. 10 to 30 degree location, first location is 10 to 30 degree north and south. 10 to 30 degree north and south western margins of the continent. Western margins of the continent. Fine? Western margins. Why do we have desert at the western margins? Can you please tell me?
माउंटेन प्रेजेंट होता है बीच में जो एयर रेन लाती है उसे स्टक कर देते हैं जाने नहीं देते
Planetary winds because of northeast trade winds
Right.
coming from the northeast direction.
Right. Which kind of winds do we have in this particular region? 10 to 30 degree north or in the tropical region? Northeast trade, not westerlies. They are easterlies. They are coming from this direction, right? These are the type of winds, trade winds, which we have in the 10 to 30 degree latitudes, right? When these winds approach this particular region, they shed their moisture in these locations, primarily here, and some amount of moisture is shedded in the interiors, right? But when they approach this region, they have almost shedded their moisture. They do not have moisture, and that's why we have less amount of rainfall here. See, deserts are not the locations where it does not rain at all. It does rain in the desert locations, but the amount of rainfall is, the amount of precipitational gain is far lesser than evaporational loss of water, right? It does rain in desert, but it is very less to fulfill or to make up for the loss of water through evaporation, right? So less than 25 centimeters of rainfall will be there in desert locations as well. Fine. So it is because of the offshore trade winds that deserts are present at 10 to 30 degree north and south western margins, right? So that is first. And added to that, the cold currents and mountainous regions, they are the factors which influence or which aggravates these conditions. Fine. Second location is this. Second location is this.
Easterly trade winds.
Northeasterly trade winds. Northeasterly trade winds. ज्योग्राफी नहीं पढ़ा है आप लोगों ने?
Sir, in south hemisphere, they are called southeasterly.
Yes. Right? See, whatever we are discussing for northern hemisphere is true for southern hemisphere, except few things. One of that we have mentioned here, right? Whatever we are discussing, it would be difficult to draw the southern hemisphere as well. Whatever we are discussing for northern hemisphere is true for southern hemisphere, except few points. First of which we have discussed already for Tundra Biome, right? So that is first. So this is the first location. Second location is this 30 to 45 degree north and south continental interiors. 30 to 45 degree north and south, continental interiors is the second location. Why do we have deserts there? Because of their continental interior locations, right? Deserts are present in this particular latitude because of the continental interior locations of these regions. As a result of continental interior locations, the westerly winds are not able to give winds to these regions, and when apparent movement of sun is there towards north, northeasterly winds are also not able to give rainfall to these regions, and hence there exist drier conditions where rainfall is far lesser than the loss of water through evaporation. Fine. So primarily it is the continental locations of these regions which makes these regions deserts. Clear? Right? For example, you can take Gobi Desert. Gobi Desert. Fine. So that is about location. Next, conditions. What are the conditions? Conditions: surplus sunlight and deficit precipitation. Fine. Surplus sunlight and deficit precipitation. Then features. What are the features that we have in desert locations? Right, xerophytic adaptability. Xerophytic adaptability. Xerophytic adaptability in plants. In plants, where we have succulent species. Succulent species. What are succulents? They are excessively dependent on subsurface moisture. Excessive dependence on subsurface moisture, succulents. Also in xerophytic condition, you can also, or xerophytic adaptability, you can also write ferrophytes. That means the plants which are xerophytic in nature, they have deep root system. They have deep root system so that they can fetch water wherever it is available. Right? So deep root system. Ferrophytes means deep root system plants. Succulent means excessive dependence on subsurface moisture. Right? Xerophytic means adapted to live in drier conditions. Fine. So those are the features. Species. What kind of species do we have in deserts? Primarily it is cactus, right? Various kinds of cactus we have in the desert locations. Also desert lily, aloe vera, khejri, right? So Acacia nilotica, those kind of species you may add here, right? For example, you may write cactus, desert lily, desert palm trees, khejri, it is found in India, khejri, 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 khejri. Then Acacia nilotica, Acacia, Acacia, Nilotica, Acacia nilotica. Sorry? Babulon. Right? Acacia nilotica. Fine. So those are found in the desert locations. Clear? Animals. What kind of animals do we have? Animals, see, xerophytic adaptability is related to plants, right? Similarly, in drier conditions, animals also show, animals have to adapt, right? So the adaptability exhibited by animals to live in desert locations is called as xerocole. Xerocole. Right? Xerocole means the adaptability of animals to live in desert locations. So what kind of adaptability do they exist? Do they exhibit? Sorry? They sweat less. Yes, nocturnal in nature. Nocturnal. Right? One of the adaptability is nocturnal. That means they are active during night. One more. Aestivation. 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 What is aestivation? Right, right. See, in harsh conditions, in harsh colder conditions, animal species hibernate. Right? That means they reduce their bodily activities and they go into deep sleep, where their metabolism rate decreases, breathing rate decreases. Right? Similar is the condition, similar is the adaptability exhibited by animals living in desert or drier conditions. It is called as aestivation, where they reduce their activities. They make sure that their breathing rate reduces so that they are able to conserve their energy. Right? So it is, you can say, opposite of hibernation in drier conditions. Yes. Sorry? Kangaroo? Yeah, means examples we are coming to. Yes, yes, that is also a kind of adaptability. Means they produce lesser amount of urine, right? That means their urine is also we can say, sorry. Yes, very much concentrated urine they release, right? So that is also a kind of adaptability, right? Means whether they are they drink their urine or not. Okay, means I'm not very sure about that, but fine, means I'll check that and let you know. Right? So kangaroo rats, yes, they are there in desert, but do they exhibit this kind of feature or not? I'm not very sure right now. Fine. So these are the adaptabilities. Examples. Examples. You may write fennec fox. F-E-N-N-E-C. F-E-N-N-E-C. Fennec fox. Next, meerkat. M-E-E-R-K-A-T. Meerkat. You must have seen The Lion King. In Lion King, that small animal is there na, along with Simba. Yes, yes. Along with boar, there is animal that is meerkat. Yes, that is meerkat. Next, black-tailed jackrabbit. Black-tailed jackrabbit. Fine. And other animals you must be aware, camel and all, right? So those are the animals that you can write. So that is about the desert biome. Next now. Next, third type and the most important type, right? These two types are important, but the most important is the third, and that is forest biome. Third biome is forest biome. Forest biome. Forest biome, right? See, this is the most extensive biome that we have. It is the most extensive biome, right? And forest biome, it accounts for almost 70% of the biomass of the world. 70% of the biomass, right? And that's why it is also known as home of vegetation. It is a home of vegetation, right? Based on the availability of rainfall, forest biome is itself classified into 3 different types, right? But we'll come to those types in few minutes. Before that, let me talk about the conditions. What are the conditions? We'll be talking about location when we discuss types. What are the conditions? Surplus rainfall and surplus precipitation. Sorry, surplus sunlight and surplus precipitation. Fine. So both the conditions are favorable, and that's why we have concentration of biomass in forest biome. Fine. One more point. See, as conditions are favorable, adaptations will be minimum. Adaptations are exhibited only when conditions are harsh conditions. Fine. So this is very important point. Adaptations are shown when conditions are harsh conditions. Now, see, surplus sunlight and surplus precipitation is there, but amongst forest biome, there is a variation of precipitation, and also the availability of sunlight is different for different types of forest biomes. And based upon this availability, there are 3 types of forest biomes. First is equatorial rainforest. Equatorial rainforest. Equatorial rainforest, where conditions will be most favorable. That means there will be 24/7, not 24/7, but it rains almost daily. It rains almost daily in equatorial regions. There are no season cycles in equatorial region, right? And as it is the equatorial region, availability of sunlight will also be very high, right? So this is the location of equatorial rainforest, where it rains daily, and that's why precipitation is favorable. And also, as it is equatorial region, we have straight sunlight in this particular region, and that's why surplus sunlight is also there. Fine. So that is first, equatorial rainforest. Location you may write 10 degree north to 10 degree south. Location 10 degree north, 10 degree south. Fine. Then what are the features exhibited by this particular region? See, as conditions are favorable, we have closed forest. Feature first is closed forest. What are closed forest? Right, they are opposite of open. That means wherever there is space, there will be growth of vegetation, right? So closed forest. Second, multi-canopy forest. Multi-canopy forest. What is multi-canopy forest? Right, see, as conditions are favorable and as trees are growing from wherever space is there, they will compete for sunlight, right? And as a result of that, there will be multiple canopies. So let's say there are small trees, then there are larger trees, and then we have, let's say, smaller bushes as well, right? So multiple canopy will have in the equatorial rainforest, right? And as a result of multiple canopy, we have dark and gloomy conditions, right? Sunlight cannot penetrate through the multi-canopy forest, and that is also a feature, dark and gloomy conditions. Dark and gloomy conditions. Fine. One more feature you may write, warm and wet climate throughout the year. Warm and wet climate throughout the year. Fine. Next, species. Species. What kind of species do we have here? Hardwood varieties of species like hardwood variety of species like mahogany, ebony, balsam, rosewood, right? So these are the hardwood variety of species. Next species, epiphytes. Next, what are epiphytes? Sorry? Creepers that grow on other trees. Creepers that grow on other trees are epiphytes, right? But when they grow on other trees, they are only taking support of them. They are only taking physical support of them. They are not extracting any kind of nutrient from them, right? So they are not extracting any kind of nutrient, and that's why they are not harmful for the host plant. Fine. So they take only physical support. They do not take nutrients from the host. Then from where they are getting their nutrients? From air. From air they are getting their nutrients, right? So they are the epiphytes are the plants which grow on, let's say, branches of other trees, right? As they are growing on the branches of other trees, we might feel that they are parasite, but that is not the case. They do not take any kind of nutrition from the host plant. They take their nutrients from air. Fine. So that is epiphytes. Next, liana, Liana. Liana. What are lianas? They are woody vines. Woody vine. V-I-N-E. W mat likhne na. Woody vine. Right. So what are lianas or woody vine? You must have seen plants. Let's say, एक host है ये और उसके around plants जाते हैं, right? Sorry. They are not exactly.
They are of wood, but they look like creepers.
See what they are taking help, means which kind of help they are taking. See, we have discussed that there are dark and gloomy conditions, right? So to access sunlight, they take help of these plants, right? They are just taking, again, these are also taking physical support of the host. They are not extracting any nutrient from them, right? Lianas, they take only physical support to get access of sunlight. Fine. So that is about the species of plants in the equatorial rainforest. Do we have animals in the equatorial rainforest? Yes, yes, we have animals. Primarily, we have insects in these habitats. Insects, and it is the home of insects as well. Along with the home of vegetation, it is home of insects as well. Why? Because it rains almost daily, and that's why waterlogged conditions will be there. Added to that, dark and gloomy conditions are also there. Due to that, we have insects in this particular region. Fine. But large terrestrial animals will be missing from the equatorial region. In equatorial region, we do not have large terrestrial animals. Do we find, let's say, tigers, lions in Amazon rainforest? No, we do not. We do not find it, right? What kind of other animal we have here? We have reptiles. We have reptiles here. Also, we have apes. We also have apes in this particular location. Along with reptiles, reptiles, we also have apes. And there is a kind of adaptation that these apes show. They show arboreal adaptability. They show arboreal adaptability. What is arboreal adaptability? They are tree dwelling. They do not touch ground because ground is filled with insects and reptiles. Yes, they live entire life on trees. They hardly touch ground because ground is not very suitable for life given the insects and reptiles. Fine. So that is about equatorial rainforest. This is the location of equatorial rainforest. Next is second type of forest biome, that is deciduous forest. Deciduous forest. Second type is deciduous. Deciduous forest. Deciduous forests are of two types. First, that is the classification that is true for India. Moist deciduous, dry deciduous is the classification which is true for India, right? So, tropical deciduous, deciduous and temperate deciduous. Temperate deciduous. Tropical deciduous and temperate deciduous. Location you may write. Location you may write. 10 to 30 degree north and south. Eastern margins we have tropical deciduous. 10 to 30 degree north and south, eastern margins we have tropical deciduous. Also in 30 to 45 degree eastern margins we have tropical deciduous.
Same north and south?
Yes, north and south. 30 to 45 degree north and south, eastern margins tropical deciduous. 45 to 60 degree north and south, on both eastern and western margins we have temperate deciduous. We have temperate deciduous. Both the margins, eastern and western. Fine. That is the location. Features. Features. So in these forests, whenever it rains, we'll be finding the forest lush green. But during summer season, they shed their moisture. They shed their leaves because of lack of availability of moisture. Right. So shed leaves during summers. They shed their leaves during summers. Next, they are closed forests. Closed forest. But when we compare this closeness of deciduous forest with the closeness of equatorial rainforest, then equatorial rainforests are more closer than the deciduous forest, right? Equatorial forests are more closer than deciduous forest. That means in equatorial forest we have dense undergrowth, but in deciduous forest undergrowth will be there, but it will not be as dense as equatorial forest. Fine. Next, species. Species. For species, firstly you may write about the deciduous, tropical deciduous. Firstly, for tropical deciduous. So, what are the famous tropical deciduous species that you know? Sal, teak, right? Sal, teak, shesam, right? So, these are important species. Even sandalwood, right? Sal, teak, shesam, sandalwood, neem, right? So, they are for tropical deciduous producers. Animals like elephants, lions, tigers, deers, puma and all, right? The animals that we find in India, you can write those animals because most of the Indian forests are tropical deciduous forest, right? Next, for temperate deciduous now. For temperate deciduous. Temperate deciduous. Producers are oak, maple, chestnut, walnut, cherry, birk, fine, and animals are like foxes, squirrels, black bear, fine. So, these are the species that we have in deciduous forests. Next now, third type of forest. We are coming to third type of forest. See, though we have written conditions as common, that means surplus sunlight, surplus precipitation. You'll have to understand that the most favorable conditions will be there in equatorial rainforest, right? The availability of rainfall and sunlight will slightly decrease for deciduous forest and it will further decrease for coniferous forest. Tropical and temperate, it is the difference of location. Are you getting these things? Ayana. Fine. Next is coniferous forest. They are also known as boreal forest, and also the most popular name, taiga forest, right? So, that is those are also the names of coniferous forest. So, what is the location? Location is this is taiga, 60 to 70 degree north and south, 60 to 70 degree north and south. Fine. Features. What are the features of coniferous forest? Cone shaped trees. Pure standing trees. Pure standing forest. What are pure standing forest? See, when we say pure standing forest, we are referring to the, you will be able to clearly differentiate the stand of trees, right? Okay, this is one tree, this is second tree. You will be able to differentiate it, but that is not possible in equatorial rainforest and also in tropical deciduous forest, where we have dense undergrowth, right? Here we do not have dense undergrowth. Why? Because conditions are favorable, but they are not as favorable as equatorial rainforest or tropical deciduous forest. And that's why you can easily differentiate the stand of different trees, and that's why they are called as pure standing trees, right? Also, these forests are known as open forests. They are also open forest. Why open forest? Because of lack of undergrowth. Lack of undergrowth. Right? Then species. What kind of species do we have in coniferous forest? Species, softwood species like pine, devdar, softwood species like pine, devdar, spruce, larch, 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 and fir, Fir, fir. Animals or consumers, caribou, 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 yak, grey wolves, wolverines, Wolverines, wolverines. Next, bears, and lynx, Lynx. It is a kind of cat, thoda sa bada cat, but not exactly leopard, right? So that is about coniferous forests. Fine. So these are different types of biomes that we have in the world. Yes, conditions are same, but you can say these are the conditions for equatorial rainforest. You may write moderate sunlight, moderate precipitation for deciduous forest, right? Then you may write, let's say, for coniferous. For coniferous, let's say we may write sufficient sunlight, sufficient rainfall, right? But these conditions, if we talk about forest, if we talk about the conditions within forest, these conditions are for equatorial forest, equatorial rainforest, right? Because they are there at this particular location where we have surplus sunlight and surplus precipitation. As we go towards the higher latitudes, for tropical deciduous, it may not be surplus, it may be moderate, right? Moderate sunlight, moderate precipitation. Then for temperate deciduous, for taiga, it will be sufficient sunlight, sufficient rainfall. Fine. But if we compare forest with different biomes, then this kind of condition is for all the types of forest. Clear? Amongst forests you can differentiate, but as a whole forest will have this kind of condition where surplus rainfall and surplus sunlight will be there, right? So that is about the forest biome. Now we have these three places to feed, right? So firstly we will discuss about this. What is this? Which kind of biome is there at that location? Here. Savanna. Fourth is grasslands. Fourth is grassland biome. And when we say only grassland, we are talking about temperate grasslands, right? We are talking about temperate grasslands. Which temperate grasslands? Steppes and prairies. Steppes and prairies. Fine. So location. This is the location of grasslands. This is the location. That means 45 to 60 degree north and south continental interiors. Location is 45 to 60 degree north and south continental interiors. Continental interiors. Clear? That is the location. Conditions, what kind of conditions are there? Moderate rainfall and moderate sunlight. Moderate rainfall and moderate sunlight. Right? So these are the conditions. See, grasslands are of two types. First is steppes and second is prairies. Steppes, prairies. And on what basis we are classifying grasslands into steppes and prairies? Sorry? Country. Not on the basis of country. See, it is on the basis of availability of rainfall. Right? Availability of rainfall. Why I have not written it? Now I'll be writing. See, this entire location is grassland. But if we divide them among steppes and prairies, then on the margins we'll have prairies. On the margins we'll have prairies. And in the absolute interiors we have steppes. Why? Because see, at prairies location, the rainfall will be bit favorable compared to steppes. Rainfall will be more than steppes at the locations where we have written prairies, right? And in the absolute continental interiors, we have steppes because of limited amount of rainfall, right? And as a result of this, there will be influence on the height of grasses as well, right? So, steppes are shorter grasses and prairies are taller grasses, right? So, why shorter and taller we have discussed. It is the result of availability of rainfall. Clear? Next. See, steppes and prairies, they have different names in different continents. Fine. So, you may firstly write about steppes, different names for steppes. Names for steppes firstly. Steppes. Veld, V-E-L-D-T, Veld in South Africa. Veld, V-E-L-D-T in South Africa. Downs, Downs in Australia. Next, Eurasian steppes. Eurasian steppes in Ukraine, Russia and Kazakhstan. Ukraine, Russia and Kazakhstan. Next, for prairies you may write Pampas. Pampas, Argentina. Pampas, Argentina. Entre Rios, E-N-T-R-E, Entre Rios, R-I-O-S, Entre Rios. Where? Uruguay. Uruguay. Next, Canterbury Plains. Canterbury Plains, C-A-T-E-R-B-E-R-R-Y, C-A-T-E-R-B-E-R-R-Y, Canterbury Plains. Where? New Zealand. New Zealand. And Simply Prairies. And Simply Prairies in North America. In North America. Fine. So, these are different names. Now, next, features. Features of grassland biome. What are the features? Features. Fine. Dominated by grasses. Dominated by grasses. That is the first feature. Second, highly nutritious grasses. Highly nutritious grasses. Sorry? Alfalfa. See, alfalfa grasses are seen everywhere. Means they are available everywhere. They are not only restricted to grasslands. Even you must have, while discussing while discussing nitrogen fixation, we have referred to alfalfa. They are found at many locations. They are not only restricted to grasslands. Fine. What you have written? Highly nutritious grasses. Next, highly fertile soil. Highly fertile soil, and because of highly fertile soil, grasses are nutritious, right? And that's why this region is famous for dairy industry. Dairy industry, and also these locations are called as granaries of the world. They are also called as granaries of the world. Why they are called as granaries of the world? Let's say suppose we clear grasses and we start cultivating that land, we will be able to get bumper crop, right? So bumper production is possible, and that's why they are called as granaries of the world as well. Clear? Fine. So that is about grasslands. Next, animals. See, why we are not writing plants? Plants are in the form of grasses only, right? Animals. Animals. Bison. Bison. Prairie dog. Prairie dog. Antelope. Antelope. Wolves, etc. Wolves, etc. Next is, so now we are left with these two. Firstly, we will be discussing this, and it is savanna. Savanna biome, also called as tropical grasslands. Tropical grasslands. They are also called as tropical grasslands. Fine. Location. Location is 10 to 30 degree north and south. 10 to 30 degree north and south. Fine. Features. Features. Primarily dominated by grasses, but trees are also present, right? It is primarily grasses, but along with grasses, trees are also there. But often trees are leafless trees. Leafless trees. Why leafless trees? Because the rainfall is not as sufficient as forest. And that's why trees, if they have to survive in these savanna biomes or tropical grasslands, they shed their trees to reduce their transpirational loss of water. Fine. One more. They are home for terrestrial animals. Home for terrestrial animals. Home for terrestrial animals. And these are the locations. These are the locations where people go for safari, jungle safari, right? For example, Africa. What is that? Masai, some location is there. Masai tribes, but Masai Mara, I think, right? Kenya ka part. Masai Mara, I think. That location, means you must be able to find it on YouTube. Many times the animal videos are from that location only, right? Masai Mara. So that is, people go for safaris there, right? Next, species. Species. Before species, can you write different names? Names before species. names. In Brazil, they are called as campos. In Brazil, they are called as campos. And in Venezuela and Colombia, they are called as llanos. Campos and llanos. Right? So these are the names. But apart from Brazil, Venezuela, and Africa, they are also present in Australia. They are also present in Australia. Right? Do we have savanna in India? Do we have savanna in India? Yes, we have. Yes, we have. You may categorize, let's say, the Gir forest in savanna. Right? Even the Kuno Palpur location can be categorized as savanna in India, where we have grasses, but at the same time we also have the presence of trees, right? But dominance of grasses is there in those locations. Clear? Next. No name as such, but they are present in Australia. Different names are there in Brazil and Venezuela only, right? Not in Australia. Next. Species. Species. Producers are grasses. Producers are grasses, where we have two specific grasses. Red oat grass. Red oat. Oats ka oat. जो morning breakfast को oat. And Rhodes grass. Rhodes. Jaunty Rhodes. Rhodes. Rhodes grass. आप लोगों को नहीं पता होगा जॉन्टी रोड्स, क्या पता है? नहीं पता? क्रिकेट देखते हो आप लोग? अच्छा, इसलिए नहीं पता. जॉन्टी रोड्स क्रिकेट देखते हो? नहीं देखते? हाँ, आज है इंडिया पाकिस्तान. जॉन्टी रोड्स he was the most iconic cricketer of South Africa, right? Very famous for his fielding skills, right? ये आजकल के तो मतलब inspired from Jaunty Rhodes. He was doing those kind of things in that era, right? Early 90s, in that time, early 90s or late 90s. उस time में खेल रहा था. Fine, no problem. Consumers. So the animals that you can cite whenever you go for safari, you can write here. All the animals, lions, elephants, leopards, cheetahs, giraffe, zebra, right? All those animals you can write here, because in this habitat or this biome is a home of terrestrial animals, right? So all those animals you can write here, right? So that is about savanna. Clear? Next now. Next, sixth one and the last one. What is the sixth one? Which is this location? Mediterranean biome. Mediterranean biome. Mediterranean biome. Right? What is the location? Location is 30 to 45 degree north and south, western margins of the continent. Western margins. Condition. Long dry summers and wet winters. Long dry summers and wet winters. Right? So summer season, they often face droughts. Fine. And in winters, they have scanty rainfall. Next, features. They are called as gardens of the world. Gardens of the world. famous for citrus variety of fruits, citrus variety. And as a result of that, they are also famous for wine industry. Now you can write WINE. Wine industry, famous for wine industry. Clear? Fine. One more. See, one of the features of this location is that here we have the influence of forest fire, and forest fire is used as a mechanism for nutrient cycling. It is also used as a mechanism for germination of seeds, right? So this is very important feature of Mediterranean biome, where trees have the influence of fire. They are called as fire loving trees. They are called as fire loving trees. Or in Mediterranean biome we have fire loving trees. Why they are fire loving? Because they use fire for germination of seed and also for nutrient cycling. We have discussed nutrient cycles. So for nutrient cycling, fire is used. Have you seen eucalyptus? Have you seen its seeds? They are very unique kind of seeds, right? So for germination of those seeds, fire is important. Fine. So fire loving trees are there in Mediterranean biome. Example. Now species. Next is species. What kind of species do we have in Mediterranean biome? Olives, figs, olives, figs, rosemary, lavender, citrus trees, next, pyrophytes, pyrophytes, pyrophytes. In bracket you may put fire loving trees. Consumers or animals. So not very famous for animals, but goats, rabbits, lizards are there in this particular location. Fine. So that is about the biomes of the world. Clear? So those are the 6 important biomes of the world. Tundra, then desert biome, then forest biome where we discuss equatorial rainforest, then tropical deciduous, temperate deciduous, and also taiga, which are also called as coniferous or boreal forest. Then we discussed about grasslands. When we say grasslands only, it is temperate grasslands. Then savanna, which are also called as tropical grasslands, and then Mediterranean biome. Fine. Next. Apart from this, we should also discuss one more biome, and it is littorals. Littorals. They are not exactly terrestrial biome. They are a transitional zone between land and water. They are transitional zone between land and water. 7th is littorals. Littorals. For example, let's say you are standing on land and you want to go into sea, right? When you start walking towards sea, there will not be any abrupt change from land to water. Okay, यहाँ पे land खत्म, यहाँ पे पानी शुरू. No, that will not be the case, right? You will find that there is a gradual change. There is a gradual change in the conditions, right? Initially, you will have let's say mud, which is you will have mud. That means moist soil will be there. Then the level of water will increase, right? Initially, let's say few centimeters, few meters, right? Few feet, and then few meters, right? So that way you will encounter the ocean. It will not be a direct change from land to water. Fine. So the ecosystem or the biome which is present between land and water, where conditions are not exactly similar to land or water, is littoral. Right? So conditions are transitional between land and water. Here we will not write conditions in the context of biomes that we have discussed earlier. That means surplus rainfall, sunlight. Those kind of conditions are not applicable to littorals. Conditions are transitional between land and water. Right? And as conditions are very unique, they are not exactly terrestrial nor aquatic ecosystem. And that's why we have very peculiar kind of vegetation, very peculiar kind of living beings that live in these particular locations. Fine. For example, we have mangroves in these locations. Mangroves, right? Mangroves are a kind of plant species where in which we have certain kind of adaptabilities. See, conditions in littorals are very unique, and that's why in order to sustain in that location, littorals or the vegetation present in the littorals should show certain kind of adaptabilities. Right? I told you that adaptabilities are seen wherever there are unique conditions, wherever there are harsh conditions. Right? So in littorals there is presence of brackish water. Right? Brackish water conditions will be there. Right? That means salinity will be higher. It will not be a fresh water. There will be a presence of salt in the water in the littoral ecosystem, littoral biome. Right? So brackish water conditions will be there. And whenever brackish water conditions are there, you'll have to ensure that there are certain adaptabilities which will allow you to survive in brackish water conditions. So what are the adaptabilities shown by, let's say, mangroves species in littoral biome? One of the most important adaptability is nematophores. What are nematophores? Right, nematophores are the roots, special roots, which allow these plants in littoral biome to overcome anaerobic conditions. They allow plants to overcome anaerobic conditions, nematophores. Right? Nematophores, these are roots which help in the respiration in anaerobic conditions. Fine. One more, stilt roots they have. They have stilt roots. What are stilt roots? Apart from nematophores, they also have stilt roots. See, there are some roots which you will find coming from the, let's say, stem, right? So these roots ensure that there is proper or there is firmness in the stem of that particular tree, right? So they are stilt roots. They are for support. They are for support, additional support. Fine. How they are providing additional support? See, as a result of these stilt roots, they will trap mud. They will trap mud because there will not be firm ground in the littoral biomes. These stilt roots, given their density, they will trap mud, and as a result of trapping up of mud, there will be formation of a firm ground for the growth of tree. Fine. So nematophores are the roots which will help in the respiration. On the other hand, stilt roots help or they provide support. Right? One more adaptation is in the form of salt secreting glands. Salt secreting glands. Right? Leaves have salt secreting glands. In mangroves, we have salt secreting glands present in the leaves. Why? Because the water that they are taking inside their body is brackish water. To filter out excessive salt, they have these kind of glands, right? So salt secreting glands help them to survive in brackish water conditions, right? One more adaptation. It is viviparity mode of reproduction. Very important. Viviparity mode of reproduction. What is viviparity mode of reproduction? Right, not exactly young ones, not exactly young ones. See, in the vicinity there will be brackish water present, right? And that's why if seed is falling on the brackish water, it would be difficult for seed to grow. And that's why what happens, germination of seed occurs inside the plant. Germination of seed occurs inside the plant, and after germination it will be let's say transplanted in the external environment so that it can survive in the external environment, right? So it is germination which occurs inside the plant, not exactly creation of young ones, right? Germination of seed inside the plants is viviparity mode of reproduction exhibited by mangroves or plants present in littoral biomes. Fine. Where do we have littoral biomes? They are there in the coastal locations, right? They are there wherever coastal locations are there, and which and those coastal locations which are not, let's say, dominated by the presence of sandbars or let's say the beaches, right? Sandbars should not be there, and beaches should not be there. Otherwise, those trees won't be able to grow in that region. Clear? Right? So that is littorals. Examples you may write. Examples. Examples of producers. Rhizophora. Rhizophora. R-H-I-Z-O. R-H-I-Z-O. P-H-O-R-A. P-H-O-R-A. Rhizophora. Apiculata. A-P-I-C-U-L-A-T-A. Next. Red mangrove. Red mangrove. Black mangrove. Next, Avicennia, A-V-I-C-E-N-N-I-A, Avicennia. Right, so these are some species of plants that we have in littorals. What kind of animals do we have there? We have salt water or sea water turtles, salt water crocodiles. Right, even you can write about Royal Bengal tiger, Royal Bengal tiger. Fine. So that is about the biomes. Clear? Fine. So these biomes are very important from the exam's perspective, because often, means almost every year they are asking question on biomes. They will give you certain conditions and you are supposed to identify the type of biome mentioned in those statements. Right? Last year there was such question. Even in 2021 there was such question. Fine. Next, one more topic we'll discuss. It is Indian biomes. Indian biomes. Next topic, Indian biomes. In India, we have primarily three types of biomes. First, it is forest biome. Second, desert biomes, and one more, apart from littorals. Littorals are also there, but apart from littorals, grassland. Biome. Right? So firstly, we'll discuss desert and grassland because we'll be able to cover them today. Forest we'll discuss in the next class. Right? So deserts are again classified into two, hot and cold. Hot and cold. Right? Firstly, hot deserts. So in hot desert, what are the conditions? Conditions. It is dry and hot conditions. Dry and hot conditions where precipitation is less than 25 centimeters. Less than 25 centimeters. Fine. Where do we have these kind of deserts? It is there in Thar. Example is Thar desert. Example is Thar desert. We have three different types of plant species in this particular desert. First is ephemerals. Ephemerals. What are ephemerals? Ephemerals, you must have heard about perennial and ephemeral rivers. What are ephemeral rivers? Seasonal. That means whenever rainfall occurs, those rivers will have water, otherwise they will be dry. Right? Same is the case with ephemeral plants. Ephemeral plants are those plants which have short lifespan. Whenever it rains in these locations, these ephemeral plants will grow. They will bear fruit, flowers. They will bear flowers, fruits. They will complete their life cycle and they will die. So that is ephemerals. Ephemerals are those plant species which are able to complete their life cycle in a short time period whenever rainfall occurs in desert locations. Fine. So that is first. Second is rain perennial. Rain perennials. What are rain perennials? Rain perennials are those which will be present always, but we will be able to see them whenever rain occurs. They are present perennially, but we can see them only when there is availability of rainfall. Yes. Sorry? हाँ ओके कर दोगे. Fine. So that is ephemerals and rain perennials, and other species are those which are present, or we can say they are xerophytic. Even these are xerophytic. We should write perennials. That means cactus, right? Aloe vera, desert lilies, palm trees. They are present throughout the year because they have adapted to live in those drier conditions. Right? So these are the plant species. Animal species, camels, rodents. The most important is not rodents, sorry, reptiles. reptiles. Mammals like camels, right? Then, sorry? Burrowing animals. Fine, burrowing animals as well. Burrowing animals. Then that means rodents only. That means rodents only. Fine. There is a species of buffalo. It is not there in Thar. It is there in Kutch. Right? It is adapted to higher temperature conditions. Sorry? Bison. You may write Great Indian Bustard. Great Indian Bustard you may write because it is there in the Desert National Park. Right? Jaisalmer, Barmer. It is there in the Desert National Park. Fine. So that is hot desert. Do we have cold desert in India? Yes, we have cold desert in Ladakh, Leh Ladakh. Right? What kind of conditions are there? Conditions are dry and cold conditions. Conditions are dry and cold conditions. Again, precipitation is less than 25 centimeters. Precipitation is less than 25 centimeters. Right? So there are no features as such because this is the location where we do not have the presence of much life. Right? So species you may write, species. Just a minute. Just a minute. Okay, species I will tell you later tomorrow or day, in the next class I will tell you about the species of cold desert. Fine. Last is grassland, but we'll discuss it in the next class only. Fine. Grasslands are present in India primarily in the foothills of Himalayas. Let's say in Kaziranga National Park, you must be able to see grasses. Also, they are present in the semi-arid regions of India, primarily, let's say, Gujarat and adjoining parts of Madhya Pradesh. Fine. So there we have grasslands as well. We'll discuss it in the next class. Any doubt? Any doubt? See, you'll have to read these things.
Tropical and temperate grassland, what is the precipitation range?
Tropical and temperate grassland precipitation range. See, it will be more in savanna. Why it will be more in savanna? Why it will be more in savanna? Because generally it is at lower latitudes, right? Though they both are continental interiors, as it is in the lower latitudes, we have discussed a general rule for rainfall or precipitation. It goes on decreasing as we go on increasing sign of latitude. So it will be more in tropical, in the tropical grassland, and that's why along with grasses we also have presence of trees in tropical grasslands, right? For temperate grasslands, steppes, prairies, trees are not there, right? But in the savanna we have more rainfall. But at the same time, you should also understand that as rainfall is more, see, we are comparing tropical and temperate. rainfall is more in tropical grasslands than temperate grasslands. But at the same time, evaporational loss will be more in tropical grasslands than temperate grasslands. Right? So, exact range of rainfall is difficult to tell, but savanna will have more rain than temperate grasslands. Fine? Any other doubt? See, you will have to read these things. In the yesterday's class and today's class, I was a bit slow. From the next class, I'll be only discussing. Fine. So make sure that you read these things. See, after all, these are revision classes, right? These are revision classes. It would be difficult to cover syllabus otherwise. Fine. So make sure that you read these things at your home, so that whenever we discuss in class, you are there with the class. Fine. Okay. Please read these things. How many of you have not read environment till now? Yes, I think you have not read environment, right? Have you read? No. So, it is better that you read something. For example, the standard book is Shankar. So, make sure that you are going through the Shankar as. See, now we have covered, let's say, environmental ecology. In the next class, we'll discuss about Indian biomes, and then we'll start discussion of biodiversity. So, make sure that you are reading biodiversity. Fine. So that is the most important aspect, because otherwise you will feel disconnected with the class, right? Today and yesterday I was bit slow, but from the next class, to cover the syllabus, I'll have to be very fast. So make sure that you read, please. Okay? Okay. Thank you.